Okay, now we're going to look at the idea of derivative. The derivative is basically going to be the slope of a tangent line. First, let's take a look at what that means. Slope of a secant line is the slope of a line that goes through 2 points. The slope of a tangent line is a line that's touching the curve just at 1 point. The slope of that tangent line describes how the function is changing at that moment or at that spot. Now, how can we figure out what the slope of that tangent line is? Well, we have to use calculus. What is calculus? Well, calculus is just math with limits. So we're actually going to use the idea of limits. We're going to start with the slope of this secant line. We know what the slope of this secant line is. This is a random value of x, and then this is just x plus a little bit more. Using those two x values, we can figure out the slope of that red secant line. So if this is x, then this point is x comma f of x. If this is x plus h, then this point is x plus h, and then f of x plus h. So we have the 2 points, and we can use the definition of a slope to write what the slope is of that red secant line. So we have y2 minus y1, that's right here, y2 minus y1. And then the bottom is going to be x2 minus x1. So there you go, x2 minus x1. And I think you can see that the x's on the bottom cancel. This x and this minus x cancel, and you're just left with h. Now this is the slope of that red secant line. Now here's where the calculus comes in. We want this point right here to get closer and closer and closer to that first point. If we can do that, then you can see the slope is going to become closer and closer and closer to the slope of that tangent line. And now here's where the calculus comes in. If we do the limit as h goes to 0, then this point will get closer and closer and closer to this point here. And that means the slope of that secant line will get closer and closer and closer to the slope of that tangent line. So this here, combined with the limit, is the actual slope of the tangent line. Now the way that we write that is we write it as f prime of x. That means that's the derivative of f of x. And that's also the slope of the function f at that value of x. So that gives us the slope of the tangent line at that value of x. Okay, this formula here will give you the slope of the tangent line for any value of x. So let's do our first example. Let's try for the function 5x squared. And f of x plus h is going to be 5, and then x plus h squared. The minus f of x is just going to be minus 5x squared. And then the bottom just has an h on it. Okay, if we multiply this out, we get this, and then we're going to distribute the 5 on each piece. Okay, I want you to notice that this 5x squared cancels with this one. The next thing I want to show you is that there's an h in the bottom, and both pieces on top also have an h. So you can factor out an h and then cancel it. So we cancel the h. And now we have a plug-in limit, so we can plug in the 0 for the h. And we get 10x for our answer. What is the meaning of this? Well, what it means is that 10x is the slope of the tangent line for any value of x. So if we let x equal 1, you can plug in a 1, you would get 10 times 1, which is 10. And that will be the slope of the tangent line when x is 1. Or you could let x equal 2. And the slope of the tangent line at that spot would be 10 times 2. So it tells you the slope of the tangent line for any value of x. Okay, here's another way of doing the exact same thing. There's actually about 3 different formulas, 3 different ways of doing this. For this one, we're using a known x value, so x equals 1. And so if we just add a little bit more, you get 1 plus h. We know the slope of a line that goes through 2 points. So this point right here is 1 and then f of 1. This second point is going to be 1 plus h and then f of 1 plus h. Okay, now we're going to use the formula for the slope of a line. So we have y2 minus y1 on top, and we have x2 minus x1 on the bottom. Just like before, you'll notice that this number cancels with this number, so you're just left with an h. Again, this is only the slope of that red secant line, so to find out what the slope of that purple tangent line is, we're going to need to do the limit as h goes to 0, and that'll allow this point to get closer and closer and closer to that left point. If we do that, then the slope of this secant line is going to get closer and closer and closer to the slope of the tangent line. So we put the limit in front of it. So this is another formula you might see. And instead of it being a 1, it can actually be any value of c. So I took the 1 out, and that gives you the formula for the slope of the tangent line for any value of c. Okay, if we use this formula, we're going to plug in a specific value of c, so we're only going to know the slope when x is 2, because our c value is 2. So we'll write it as f prime of 2, and that'll be the slope when x is 2. And the first formula we used had an x here, and this formula has a 2 here. So when we're done, we're only going to know the slope when x is 2. Okay, first let's multiply this out. Okay, we're also going to multiply this out. 2 times 2 is 4. Then we'll distribute the 5 on each piece. Again, just like before, the 20 will cancel with the minus 20. And we can factor out an h from the top and from the bottom and cancel it. Okay, we cancel the h. We can plug in the 0 for the h. And we just get 20. What does this mean? Well, we chose a c value of 2, so what it means is, it means when x is 2, the slope at that spot is going to equal 20. So the slope of the tangent line when x is 2 is 20. Now you may see this written as f prime of 2 is equal to 20. Okay, now we're going to look at even another way that you can do it. If we call this value x and this value c, so this point is going to be c and then f of c, and this point is going to be x and then f of x. Just like before, we're going to use the slope formula. We want to do y2 minus y1, that goes on top. Then we want to do x2 minus x1, and that goes on the bottom. Again, this is just the slope of that red secant line. What we want is the slope of that dotted purple tangent line. So we need this point to get closer and closer and closer to the point of tangent C. So we're going to need to take the limit as x goes to c. Now this is kind of like the last one where the c is a constant value. So the slope that we're looking at here is just going to be the slope of the tangent line at a particular value of c. You're not going to be able to plug in any value of x that you want when you're done. Okay, let's do an example. When c is 2, what is the slope? Now this is just a little bit different of a formula. We've already done this one. We know that the slope was 20, so when we're done we should get 20. So we'll plug in our function, see what we get. So f of x is just your function. Now f of c, when c is 2, we just plug a 2 for the x. Now the formula says on the bottom x minus c, so we're going to have x minus 2. And remember, x was supposed to go to c, so our x is going to 2. Let's go ahead and solve it. Okay, if I multiply the top out, this is what I get. Now you'll notice you cannot plug in 2 because if you plug in a 2, you're going to get 0 over 0. So this is one of those factor and cancel limits. We've got to take a 5 out of the top. Then we can factor the top further. It's a difference of squares. Now we can cancel the factor of x minus 2. And now we're left with a plug-in limit. And we get 20 for our answer. What does this mean? Well, again, it means when x is 2, the slope of the tangent line is 20. Okay, now we're going to do kind of a challenge one. We want to do the derivative of cosine. So that's going to be a really tough one. We're going to have to remember a certain formula in order to do it. Cosine of x plus h is cosine x cosine h minus sine x sine h. That's going to be important. And also, we're going to use our special trig limits that we learned before. So here's our formula. This is the most common one that's used. Our function is cosine of x. So that's just going to go for f of x. For f of x plus h, we have to replace the x with x plus h. Now here's the first tricky step. We're going to have to trade cosine of x plus h for all this stuff right here. Now you want to notice that there's a cosine here and a cosine here, so we can factor out the cosine from those two pieces, and you would be left with cosine of h minus 1. Now this entire piece we just bring over here. Now we're going to break up this big fraction into two fractions. They're both going to be over h. And on the left side we have cosine over 1, and we have this stuff over h. Don't forget to bring the minus down. Over here we have sine over 1 and sine of h over h. Remember, they both had an h on the bottom. Okay, when we do this limit, it's a limit as h goes to 0, but there is no h. So you just get cosine of x. This limit is a special limit. That is going to give us a 0. Again, for this one, we're doing a limit as h goes to 0, but there is no h. So you just get sine of x. And this is our other special limit. This limit gives us a 1. So our final answer is just going to be minus sine of x. Now, what does this mean? Well, it means for the cosine function that the slope at any value of x, we're going to call that f prime of x, is going to equal negative sine of x. Okay, one of the things we're going to do is try to go backwards. If we see a limit, instead of doing that limit, you saw how long it took to do those limits, can we just recognize that that's just the derivative of some function, right? Or the slope of a tangent line for some function. Now, one of the tricks that I do to help me figure out what function it's the slope of or what function it's the derivative of is I just try to ignore the h. If you ignore the h, you're left with 3x squared. And so this limit here is really just the slope of the tangent line for the function 3x squared. Another way of writing this is that this is the derivative of 3x squared. That's what this limit is, the derivative of 3x squared. And so the answer to this is going to be the slope of the tangent line for any value of x for the function 3x squared. Again, if we ignore the h, we're left with 310 squared, but 10 is actually our particular value. So it's kind of like 3x squared, but when x is 10. Okay, remember this limit is really the slope of the tangent line, so we're going to say that this is the derivative of 3x squared when x is 10. Now, how can we check that? Well, if we were doing the derivative of 3x squared, we would have a 3, an x plus h, and then a squared, and then minus a 3x squared, all over h. But if we want a specific value of 10, then we would have to plug in our 10, so we would get a 10 right here. And if we plug a 10 for this x, we're going to get 3 times 10 squared, so 3 times 100, and that gives you the 300. So this limit represents the derivative of the function 3x squared at a particular value of 10. Now this one was that special rule, the one that was a little bit different, when you do the limit as x goes to c. So it's probably going to be at x equals 3. Our c value is probably going to be 3. And if you see the rule says that your function is just sitting right there. So our function is probably ln of x. So I would say that this limit represents the derivative of ln of x when x is 3.